In this lesson, we're going to look more at equilateral and isosceles triangles and kind of go back to what we know about them and how to use some theorems to work with finding missing sides, angles, etc. So first, let's talk about the equilateral triangle corollary. It sounds fancy, but it's really something you already know. Basically, if a triangle is equilateral, then it is equiangular. And the equiangular triangle corollary is basically the opposite of that. If the triangle is equiangular, then it is equilateral. Let's go ahead and just jot that down real quick. All right, so that's that first one, the equilateral triangle corollary. So again, you're given the equilateral triangle, so all three sides are congruent, either in the diagram or you're given that information, right? AB is congruent to AC, which is congruent to BC. Then we can say all three angles are congruent. And then using our triangle sum theorem, you can even go further and extrapolate that. We have 360-degree angles, right? So then basically the converse of that is our equiangular triangle corollary. So let's jot that one down. Okay, so there's our second corollary. So again, basically the converse, we're given the equiangular triangle, so we know all three angles are congruent. Angle A is congruent to angle B, which is congruent to angle C. Then we can conclude that it's equilateral, meaning all three sides are congruent. So again, nothing super new here, just making sure we see that equilateral and equiangular here related. And we can use that to help us solve problems, right? So if I look at example 1, I want to find NP. How would you set up your equation, solve for NP? Well, hopefully you see it's pretty straightforward. We know that our triangle is equiangular, which means the triangle is equilateral. So that means I can say 5y minus 6 is equal to 4y plus 12, right? Then you can go through, do your inverse operations to solve, just like in algebra 1. So we'll get y is equal to 18. And then since I'm finding NP, I'm going to plug it in to find NP. So 5 times 18 minus 6, which should get me 90 minus 6, which is 84, right? So there's my answer. Part B, now we're using the other corollary. So if I need to find x, notice how x is an angle, but I have no information about any other angles, but I know this triangle is equilateral, which means every angle is what degree? Every angle is 60. So there's my equation, right? Since, again, we have an equilateral triangle, that means it's equiangular. Since it's equiangular, 180 divided by 3 is 6. So go through and solve, and we should get x equals 14. Right? Doing whatever work, we should get x equals 14. So just rehashing what we know about equilateral, kind of a nice way to sort of start winding down in chapter 4, going back to what we learned at the beginning. And let's move on to isosceles triangles. Okay? The isosceles triangle theorem, what does this tell us? All right. My dog's done? Okay. Isosceles triangle theorem, what does this say? Remember, isosceles triangle has how many congruent sides? Okay, well, an isosceles triangle should have 2 congruent sides, right? So it could look something like this, right? We can have ABC, where AB is congruent to BC. What else would this tell us? Well, the isosceles triangle theorem says that if you have 2 congruent sides, we're going to have 2 congruent angles. And those congruent angles are going to be the base angles. So the base angles are going to be the angles that these congruent sides kind of point at. All right? So these are what we call base angles. The isosceles triangle theorem says that if your triangle is isosceles, then the base angles are congruent. So let's jot that down first, and then we'll finish off that diagram. All right, just a reminder, if you need to pause to write the stuff down, definitely do so. But I'm going to continue talking. So if we are given this is an isosceles triangle, meaning we know that AB is congruent to BC, right? We're given triangle ABC, and we know 2 sides are congruent. AB is congruent to BC. Then we can say that the base angles, the angles opposite the congruent sides, this angle A and angle C, they must be congruent. So angle A is congruent to angle C. Okay. The converse of the isosceles triangle theorem is basically the opposite. So again, we could be given any old triangle here, and we would say that the opposite of the isosceles triangle theorem works here. So basically, if you have two base angles that are congruent, then we have an isosceles triangle. We have two sides that are congruent. So let's jot that down first, and I'll look at the diagram. Okay, so again, just fleshing that a little bit more. So if you have two angles that are congruent, any two angles, those will become our base angles. And then we would know that the triangle is isosceles, meaning that the two sides opposite those angles are going to be congruent. So for example, if we are given angle X is congruent to angle Z, right? We're given triangle ABC, or, ooh, my bad, triangle XYZ, and we are also told angle X is congruent to angle Z, then we can conclude the sides opposite those angles. So if you follow the angle, this dash mark here, it should point at the opposite sides there. We can conclude that sides XY and YZ are congruent. So that's the converse of the isosceles triangle theorem. Okay, let's take a look at example 2 and let's apply our isosceles triangle theorems here and see what we can do. So we want to find the measurement of angle H, and notice what's special about this triangle. It's isosceles, which means what do we know about these two angles, J and G? Oops. So let me back up and fix my screen. Technical difficulties? No problem. All right. So again, what do we know about angles J and G? Well, remember, your opposite angles from those congruent sides should be congruent. So we should know that angle G is congruent to angle J. This is your isosceles triangle theorem. Which then means, how would I set up my equation? Well, x plus 44 is going to equal 3x. Now, how is this going to help me find angle H? Because I want angle H, right? How is x going to help me find angle H? Well, remember, what do you know about all three angles in a triangle? Remember, all three angles sum to 180 degrees. So I'm going to keep that in mind as I'm working this out, because once I find x, I can find g and j, and then take that from, add them together, take them away from 180 to find angle h, okay? So here, solving for x, doing your inverse operations, we're going to get x is equal to 22, which means the measure of angle j is 3 times 22, which is 66 degrees. And since the measure of angle G is equal to the measure of angle J, that's also 66 degrees. So then to find the measure of angle H, I know that H plus 66 plus 66 should equal 180 by my triangle sum theorem. So you want to make sure you can, apply the different theorems we learned. It doesn't have to be just one theorem at a time. We can do a few at a time here. So here we're using the isosceles triangle theorem plus the triangle sum theorem. And we are going to get 48. So again, add your 66 plus 66, take it away from 180 to get the measure of angle H is equal to 48 degrees. But again, that was the triangle sum theorem plus the isosceles triangle theorem. All right, take a look at example 2. And what if I have two triangles put together and I want to find the value of x? Do some critical thinking, right? Just think through what I know and what do I need to know. I'm trying to find value of x, and I need to know this angle too. Well, how do I get there? What does the isosceles triangle theorem tell you? Because notice, these are two isosceles triangles. So that tells me that this angle should be congruent to that angle over here. So this is also 68. All right, so since I know these two angles are 68, and remember, this is measure of angle 2 is part of a 90-degree angle. So notice it's complementary with whatever this is, and I can call this x. Or let's not use x. Let's call this a because we already have an x. So let me just jot down what I know. I know the measure of angle A plus the measure of angle 2 is equal to 90 because they're complementary, right? There's this lovely 90-degree angle. Don't assume it's 45 and 45, right? Nothing tells us it's a bisector, so assume nothing. We want to figure out A. How would I find A? Remember, the triangle sum theorem says the measure of angle A plus those 268 degrees should equal 180 degrees. So once I find A, I'm going to plug it in to figure out the measure of angle 2, which then I can use to solve for x. So let's go ahead and do that. All right, so I'm going to go ahead and first do this part and solve for measure of angle A. So you do that math, we should be getting 44 degrees. So then what I can do now is say, well, 44 degrees plus whatever the measure of angle 2 is would equal 90, and angle 2 is 4x minus 2. So that should equal 90 degrees. So then I can do that math work, and I should get 12. Yep. So x is equal to 12. Right? And if I wanted to, and let's say, for example, I needed to keep going and I need to find the measure of angle 3. You know how you would do that? Notice again, we've got a couple of isosceles, another isosceles triangle here. So if I needed to find measure of angle 3, I could keep going and say, well, angle 3 plus whatever that is, which I can call y, are congruent. So we can say y plus whatever 4x times 12 is, or 4x minus 2 is, that should equal 180 once more. So see how that triangle sum theorem is pretty great, right? And then I can go through and solve for y and get that angle that I was looking for. So again, I just added that in just to show you how you could keep going, really. Then we would get 67 degrees. All right. So of course, we're not limited to just doing these problems. You can also use them in proofs. So isosceles triangle theorem particularly is a great one because that could help you do side, 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 or side, angle, side, because it's going to give you two sides. So definitely look for that. If you have two congruent angles, pull out that isosceles triangle theorem and see if you can do SSS, SAS, stuff like that. All right. So I will see you in class. Make sure you come back with questions. See you later.